Good afternoon, everyone. I hope your Friday's been going well. I think mine has been for the most part. Uh, we're happy to be here with you guys today to talk about technical interviews. Now, I know the fall interviewing season is coming up, or some of you guys are preparing for next summer. Getting your projects ready, and your interview skills ready for this technical interview. You know, like I know a number of you guys are great, and so as you're applying, you're going to be getting responses from companies and they're say, "Hey, we really like you. We want to give you a technical interview." And some of you might be thinking like, "Oh my gosh, what's a technical interview? I don't know what to expect." And so you go Google what a technical interview is. You see things that you've never heard of before, and you panic, right? So we're gonna fix that today. Yeah. So we're gonna what we're going to start with is a simulation of a technical interview. I got my guy David here from interview training.
Yep. What up, guys? I'm gonna interview this kid, see if he's got the chops.
Yeah, he's gonna see if I'm what's our company name?
What company?
No, I don't know. Make up a company.
All right, bro. He wants to work at Google, right?
Yeah, he's going to see if I'm Google
He's a
material.
Googler. Is he a Googler? I'll decide.
Pretty nervous, guys. So yeah. So so I guess where we'll start here is the day of the interview. You want to make sure that you're ready to talk about if you have any projects on your resume. Like you want to be ready to talk about your projects from a technical standpoint, right? Because this person who's coming in to give you this technical interview, while you may not have like a long like behavioral conversation about like yourself uh, during this interview, the portion that you will have will be like primarily like assessing like what you learned from your projects and seeing like how well you understood like the stuff that you were using. So I would recommend like going through your projects, rereading your code, especially if you haven't visited it for a while. So yeah, just to make sure that you're pretty up to date on that, because I know I've had an interview where one of my projects I hadn't looked at it over like a year and a half, and somebody asked me about it. It's like,
Yeah. Make sure you got the files too ready if they ask for it.
yeah. And then moving on from there, also having we're gonna assume that you've been, practicing your leak code. If you don't know what leak code is, it is a online platform for you to practice interview questions, and they're typically based on data structures and algorithms. What are data structures and algorithms? Essentially ways to organize data, and you use different data structures to do things in more efficient ways. Everything has its trade-offs. I don't want to go too far into that because that can be a conversation in itself, right?
Yep. For sure.
So, yeah. So now, I guess Dave, we can get started
Yeah.
with the
I gotta say, I like
interview.
the way he's explaining things. I'm more inclined to give him the job.
All right. Thank you. Wow.
Just saying.
I appreciate that.
I'm inclined. Stands out.
All right. So now the real question is, what's next? Okay. No, we're gonna head on over to our. Oh, this is gonna be weird. Okay. So.
What do you want to do?
Here. gonna send a link to myself and take the interview on my laptop. Like my typing will still show up there. So yeah.
All of this is for hers.
Yeah, yeah,
Oh,
yeah.
thank you.
Like all part of the script here.
Now we have your email?
Rambo14@gmail.com.
Please don't have me.
Well, we don't have your password, so I think you're good.
What do you guys think about the chances that any companies are gonna go back to
Oh,
on-site interviews?
while I'm doing this, any questions so far? Any at all? Yeah.
Is there a lot of leak code involved when you're trying to apply for a PM role, essentially?
I don't think so.
No.
No.
For at most they may ask you like some CS concepts just to see if like
Yeah.
you know you have good fundamentals, but beyond that, no, because you wouldn't really be dealing with that stuff.
Yeah. Don't worry about that for PM roles.
No,
PM roles,
yeah.
you don't have to do that much leak code, or testing a little bit, but
I ask because that's what I'm actively pursuing.
okay.
That's why
Yeah.
it came up. I know. I think it was Daniel that said if anyone was at that UPE meeting, that he had one leak code question. But then I asked him is that they can ask you on a range of things.
Did he say the difficulty of that question? Did he make a
said it was
mention?
medium.
Medium?
Yeah.
Okay. Well, just, in case, just be prepared and do practice your leak code mediums. Go over the blind 75.
Yeah.
Yeah, I was gonna say too, it's a good point. I think it depends on your company.
Yeah. Every PM role is different for each company. Like Microsoft treats their PM role much more differently than I'm assuming Google might.
Yeah.
Same thing for other big tech companies. So it varies.
Yeah.
It's a lot of it's a lot of hats you're juggling, kind of.
Yeah,
Mm.
And
Yeah.
either way, practicing your lead code as well too, because
Yeah.
so what some people do is they go into SWE first, which is software engineering, and then they go into PM. So in case that directly going to PM doesn't work, you always have the other.
Yeah.
Yeah. Always, you apply for a role, right? And it may not be SWE or the job you want, but since you're in the team and maybe a need fills and you want to switch roles, do that. All you need is that foot in the door. That's it. So, are we ready with the?
Almost.
Okay. See, well now I'm inclined to not give him the job because he's taking for it. No, I'm just kidding. I'm just kidding.
I'm sorry.
So
He's actually my boss.
wait, David,
Mm.
usually in a company, will they send you something like this?
Yeah, actually, this looks about right. When I interviewed, it was like this. It looked like this.
So
You-
tell us about DocuSign.
Okay.
How
Well,
did it start out?
well, I interviewed with 3 people in one day, so I would get like something like this. They would explain it, give me the text, and they would be ask me questions. Okay, how would you approach this? Okay, what kind of code would you put for this? So while you're writing code, you also have to be able to explain what you're doing, right? Because if you're just writing code, they don't know how you're thinking. They don't know how you're approaching a problem. They want to be able to see that. If they're not able to see that, then they don't know if you're also able to explain what you did to your coworkers, right? SWE is a collaborative effort. You want to be able to explain to your coworkers what you're doing. And if you can't do that, they're probably going to put you down on the list of considerations. So keep that in mind, right? Because there's multiple layers to the hiring process.
Is it better? Would you say it's better? Let's say if you don't get the solution, that if you're interacting with the person that's interviewing you, would look much more better than you think.
I'd
or
say it
is
depends on the company, but I think better. I think it's better. I think it's better.
Yeah, because I haven't been there yet, but I'm assuming if you're actively communicating with someone,
Yeah.
it looks
Yeah.
much better.
I mean, yeah. I mean, I mean, if you can get the solution and you can get it fast, that's also pretty good. That'd be nice too. But I mean, we're only human, right? And you want to interact with another human. And if your interactions are good, you have good social skills, they like that, right? They prefer that. But it depends on the company too, you know. But yeah, you want to do PM, right?
Yeah.
That's definitely good.
Yeah. And for example, I haven't taken discrete structures, or have like 2 semesters ago, but I
Yeah.
haven't brushed up on it. Is it something that you would recommend to brush up on? Like,
Not that.
no?
Nah.
I think maybe you were thinking about data structures.
Data structures.
Oh,
Sorry, yeah.
for sure that. Yeah. No,
Yeah.
no. That is the crux. That is what you need to know to solve these problems. That is precisely what you need to know. And that's kind of why we have the interview training community, which is to kind of help you brush up on your data structures and kind of just go through about everything. And now it appears that that we are ready to start this interview, mock interview, and I just press X.
Huh?
I just press X.
Yes.
Oh, okay, okay, all right. So now he's gonna work on his computer, and we're both sharing this problem, right? Is that what's happening? So the problem, sir, that I'm giving you is given two strings s and t. Return true if s is a subsequence of t, or false otherwise. So to explain what this means, a subsequence of a string is a new string that can be formed from the original string by deleting some letters, but in the right order. So you cannot disturb the relative positions of the remaining characters. So ACE right here is a subsequence of A, B, C, D, E, but AEC is not. So the relative positions of the letters, the characters, are disturbed. So it's not a subsequence, but here it's not, so it is. So tell me, sir, how do you solve this problem? What's your first step?
Alright, so here, first thing, like, after like an interviewer explains the problem to you, one thing you want to do is make sure like you're clearly understanding like what the objective is, right? So if you're, I mean, I don't know if like how familiar you are with subsequences, but I'll be honest, I'm not like I mean, I know what a subsequence is, but I want to like make sure I understand exactly like what makes it classify as a subsequence before I start giving what my solution to this problem will be, right? So the first thing I'm going to ask is, hey, you can ask the interviewer to give you some more examples, this to get a better idea of like what the patterns are in this problem, right? So what can you give me a couple more examples of the output for this?
Sure. So if I say, I guess I can continue counting. I have s equals a, b, and t equals a, t, a, e should return false.
Okay.
The two examples.
Right. So if S is A B and then T is A B A C E, it returns false because it doesn't contain A A B in that particular order. Even though it has A A B, since it's not in the order that it's in S, that means T doesn't not have a subsequence S inside of it, right?
Yeah.
So one thing we can say is here, like, it seems as though the only thing that matters is the order. The order matters. It doesn't matter where they occur in the string as long as they're in order. So that means like if there was another A in, I mean, if there was a B that happened later on in T, like if he added a B at the end, then that would be a subsequence, right? Because there would be AAB. But since it wasn't, yeah, it's false. So now that I have like a solid idea of how the subsequence works, I go about giving my solution. Before I do that, are there any questions?
You want another example?
Yeah, sure. Can we get?
Yeah, quick question.
Yeah.
When you have to return, like, what's the type of,
A boolean. So I have to return true or false. That's why he put
okay.
under
Oh,
it.
okay. Return true.
All right.
Few more. Kind of gave it away with this one.
Yeah, that was a little bit too much.
A little bit too, like,
Yeah.
maybe I made it too. I'm being very generous because I think he's very cool at explaining things, right? So, and I like his hat.
Thank you. Thank you. Wow. This is a really nice interview.
I'm supposed to be cool. Man, I'm
That.
good company.
So if we look at a few more examples that were provided, now I can see I got to see one additional thing with this these two examples is one that if I have a empty string provided for s, that it's always going to be a subsequence because a empty like everything contains like the empty like, the empty string essentially. And then the next thing is if I have a s that's larger than t, I can never have a subsequence. So then that means that you can't have all of the letters in s if t is smaller than s, right? So then now I can say okay. So my t1 needs to be larger than s, and then all of the letters in s have to show up in t uh, in the particular order that they are inside of s. It doesn't matter what's in between those letters. Like, for example, it's for the first one up top. Wait, can you go back up? Yeah. So ACE, you see, there's ACE is a subsequence of A, B, C, D, E. I can see there's A, then C, then E, in the same order that it's inside of the string A, C, E. So all I have to check for if if s is bigger than t, I mean if t is bigger than s, is that all the characters in s occur in the same order in t.
Okay, so can you please define the method that we're going to use, for example?
Sure thing. Going to call it is subsequence. I'm going to pass in a string. Yeah, sure. Word one, and then actually word second word. Right. Actually, I should just call them S and T to leave it
Yeah,
consistent.
I was about to say that.
Yeah. Right.
Mm.
And so. Oh gosh. Yep. So that's first.
And return true or return false?
We're gonna return false.
Wait, why?
And the reason why we return false is because like t should be very bigger than like s, right?
Mm. Well, it could be the same. It can
So
be.
wouldn't that be like
Yeah, they can.
Okay, they can be the same. But T has to be bigger.
Wouldn't that be less than equal to? Or should it be like greater than equal to? Or
If S is bigger than T,
if they're equal to, then return false.
no, they can be equal.
Oh.
They can be equal.
Okay, so it could be equal.
Yeah. And
Okay, I'm gonna have to keep going. I'm sorry.
Keep going, keep going, keep going.
Yeah. So while you're like, as you're like writing your solution out, as you're writing your solution out, you still want to like be talking about what you're doing as you're physically writing your code, right? So you don't want to leave them completely in the dark just because you finished explaining. So yeah. So now I'm going to make two variables. The one that's going to keep track of the index on string S and one that's going to keep track of the index on string T.
Okay.
Right.
What are you gonna use that for?
So I'm going to loop through string T, right? And every time I see the character at the index that I'm pointing to, I'm going to add 1 to it.
Mm-hmm.
And then at the end, if my pointers reach the length of string S, that means I found every character in order in string T.
Okay. All right. So implement that. What does that look like?
Right? So now I'm going to create these two variables, right? And then, oh my gosh.
It's not really showing up here though.
Huh?
It's not showing up here.
It's not?
No, it's not.
Oh, refresh your screen.
Still the same.
Really?
Yeah.
Oh my god.
I can't see the code F.
What?
I can't see the code still.
Wait, you still can't see it?
Gosh, I never had this happen. What happens if this happens in an interview?
You refreshed it already?
I already refreshed it. Wait, hold on. Here? I did this. What was that? See. Connected. Oh, maybe now it works. No.
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 Hold on. Alright, so then I
Oh,
guess.
okay, I got it now.
Oh, there we go.
There we
Yeah.
go.
So, yeah. I was so confused for a second. I was
All right.
like,
Wait, can I ask something quick?
mm-hmm.
So during this part when you're typing out, is it okay to be silent or would you still try to be talking to the interviewers?
You still try to be like talking to the interviewer. It was just a little bit awkward, like figuring out that whole situation.
Okay, yeah.
Yeah. But like during this time I would have talked about like me creating the two variables and then saying, hey, I'm going to create this while loop that loops through like string T, and then every time I see character that's in S and T, I would increase the I would increase the S pointer and then at the and then talk about and then I return true if S index is equal to the length of string S. Like I would be talking about that as I code it. Usually I'll go like I do a flow where it's like I talk about it like step by step. Like I'll talk about the step, then do it, then yeah. And so then at the end here we're going to return if S index equal equals the length of S. And that is yeah. And so this and so at the end of your once you finish like writing out your solution, like usually you'll be asked like what's the time and space complexity of your solution. And so if you don't know what time and space complexity is, I'm not going to go too far into it, but it's just understanding how fast your programs run, right? So you'll explain, hey, this program here, I say, for example, this one runs in a time of O of n, meaning that this program will always take as long as the input. So, like, if this string, if this string was size 20, it would have to go through all 20. So, as the input grows, it grows like proportionally with that, right? There's other time complexities, some better, some worse, where if they, some may grow like at every, yeah, some may grow in a way like it takes n squared, so it takes like a squared amount of time longer for the more input you add. Some, it's consistent all the time. It really depends on it really depends on like what the situation is and what the best approach is for the problem. Yes.
So do you have any advice for figuring out time complexity? Like this one, we could see that it's O of n, but for example, if it's n log n, it's something
Mhm.
different.
Right. I would. Any specific? I I would say for like the simpler ones, like when you're finding like whether it's O of n, n squared, etc. Usually it's like the amount of nested loops that you have inside of your program. Though sometimes that can be tricky because sometimes people use, you can use like nested loops for a two-pointer problem,
How
right?
do you know when it's multiplying runtime versus adding in the code?
How do you know if it's multiplying versus adding? So like m times n versus m
Yep.
plus n. So that one is definitely a case where it'll be nested, right?
Which
Like
one?
m times m,
Okay.
m times n, because that means it's doing it does m times n loops, right?
What does
So
that mean?
that means like let's say m and n were the rows and columns, right?
Right.
That means the code, it has to loop through, it loops through all the like all the rows and all the columns that existed in that space.
So what you're saying, it goes through every cell?
Yeah, every single
There
cell.
are n times m cells.
Yeah. Whereas m plus n would go through one row, one column, or
Okay. All right. Yeah, makes sense. Okay. So
Right.
is this code done? Do you think we can test it out right now?
not with that A there. But I think we can test it out.
All right.
So,
So we're gonna print.
yes.
Do that.
And we can try,
I wrote some tests in the beginning. You probably use those.
okay.
So you can use ACE and ABCDE.
So, let's see. Oh my god. Let me just grab this.
Don't be afraid to copy and paste, you know?
Big picture, look at it.
Right? Okay.
Alright,
We could just use those. Alright, so let's run it.
let's run it. Oh my gosh. I realize now.
See, notice those things. Right? You might even have an infinite loop and you don't notice that you put an extra. That's 5 marks. You lost 5 marks, by
Oh,
the way.
You created an
Oh,
basically.
yeah.
Actually another bug in your code as well.
Oh, what?
Debug
Your
for
if your S index goes over, like when it reaches to the end of the S string.
No, no. So, oh, actually explain that, please.
Wait, what?
Yeah. He's saying that we don't check if S index goes over the length of S.
Oh, well, so that's what, in the beginning, we check if the length of S is greater than the length of T, because we want to make sure that our S can't be greater than T. So by the time I get to that point of the code, I'm guaranteed that S is at most the same length of as length as T.
Wait, actually, he brings up a good point.
What?
He does bring up a good point because you're not checking here. You could be indexing on S and you keep increasing it.
No.
Yeah,
No.
you could be doing that. Well, let's run. Let's run. Let's
All
run.
right.
Let's run. Stop. I'm running.
Oh wait.
Yeah, he had a good point.
Oh yeah, true.
Yeah. So it has to be S. S index less than S.
No.
Or you could take let S equals 0. Okay.
Hold on.
And just do both. Just to check the both.
Yeah.
Yeah. Alright.
There we go.
Alright. Good. Alright.
Thank you.
Thank you. Thank you very much. Later. Thanks for fixing that bug for us. Well. Is it fixed? Alright. And yes, this is precisely exactly what you need to do. Yes.
Would you recommend running the example problems by hand without pressing like actually?
Okay, yeah, that's a good point. So, what's a more efficient way of writing all these print statements?
A more efficient way?
Yes.
Writing by hand?
Yeah, writing it like that. Many print statements.
Yeah.
Is there a better way of doing this?
I mean, I could put it in an array and just,
Maybe.
yeah.
Let's try that.
Okay.
Probably cases maybe. Cases equal. Test cases equal.
Oh, that doesn't
Yeah.
matter. Anyway, yeah. So
You want me to do it?
no,
I'm gonna do it.
I mean we don't really need to cover this.
Well, someone has. Someone has.
But to
Cases
draw it by hand?
Yeah, write all these print statements by hand.
No, she's talking about physically writing out like before you run it.
Casey, what do you mean?
I know, for example, sometimes you might have to run the code, so that's why I'm doing the code by hand. So like, just walk through an example that actually didn't run on a compiler.
Yeah.
Oh.
Recommend doing that when you do it, or do you think that just running?
Yeah, I would recommend before you press run, not like not like what I did, that you follow through, like you read through your code and like kind of trace out your solution mentally, like making sure that everything is like clear and there's no bugs in your logic before like actually running your code, because that's kind of like
Actually, that's not such a bad idea. If they can see you're good at debugging code, that's a good skill.
yeah.
So, it's up to you. I mean, the error, go to the line, you know,
Mhm.
and then check it there, or what Clem just said.
Yeah.
Yeah, but
There-
is there a more efficient way of writing the print statement?
Yes. You don't have to go through that.
Fine. He doesn't want to go through this. I'm the interviewer, and he's asking me questions. Alright. See, I guess I'm not really the interviewer, guys. Follow along.
I mean, if we really want to, we could make units. Whatever.
Alright.
Yeah.
That's not a thing, that not wanting you to press run if it's buggy.
No, you can press run if it's buggy.
Are you sure it's like a Google Doc, right?
What?
Like I put they say it's on Google Docs, like
No, usually it'll be on like something just like this,
It'll
like
be on IDE
IDE.
that you both can see and interact with. That's
Yeah.
usually how it is. And you run it because you want to run it. It's done. So
it works. Like, you know.
Wait, and we want to be array, just using the like array, array list.
What?
You want to go be array list, string list.
What do you mean array?
Use it.
Your string will be a string array list basically in this case, because you were able to store it in during the program, and
Store what?
store the string, store the variables, the letters.
You mean store these strings in an array list and then that's, well, I think we don't have enough time to cover that.
No.
So, but, I mean, if we're just testing if this function works and this function works, you pass the test cases. You know?
Yeah.
I mean,
It works.
presumably, the interviewer will have written, test for the interview and compare it with, you know, what we just did.
Mm-hmm.
So, makes it easier on him or her. And, yeah, I mean, do you have any more questions?
Only other thing I would recommend is this problem was pretty straightforward. Like there weren't that many edge cases, but usually, right, in a problem that you're working on, while you're, I guess, going through your code, you want to try to think of like as many cases that will that could possibly make this logic break, right? Like you want to be like breaking down your own code, like to prove like every possible way this could go wrong, like to make sure your code is able to handle any possible way this could go wrong, so that it's guaranteed to be correct, right?
Yeah.
Yeah. And so now I guess that was it for this demonstration. What's it called? Hey, Gabby, Casey, can you come here real quick?